I have started the recording. This is Design 300. It's our lecture for Thursday, September 9th, and we are meeting online. And what we're going to do today is just step through a little bit more of our week 3 site and soil work, and I'll describe some of this. Just about everything that you need is in the reading list. So I really try to put everything in there for those that cannot make it to the lectures. And so I'm just going to kind of go over some more of these things and review them. And we'll look at this building pad load really quick so that you know how to do that. There's a video about it. As a matter of fact, I think that's actually the video. No, that's the Jamboard. So we'll go to that Jamboard and go over it really quickly. And then we'll just start looking a little bit about compacting dirt and reading some of these items. Welcome in, Mark. Good to have you on. Oh, and I will do the Revit exercise for you, just to show you. So let me start with the building pad loads. And this is really important. We don't think of this too often until something goes wrong. Something like the Surfside collapse, where loads were, the load carrying ability was degraded. The Millennium Tower in San Francisco, where the actual foundations were not properly supported. But the foundation, which around here is usually concrete, either in what's called a pier block, which is just a block, or a poured foundation. And it could even be something that looks like this, which is slab on grade. Those are all words that you can take notes on and look up, but we're going to do a little bit more on that next week. But the walls support the floor, the foundation supports the floor, which also supports the wall and supports the live loads on the floor. And it supports the roof, and the roof includes the trusses and the roofing material itself. And all of that creates weight. Okay, there's a force pushing down. And usually we'll suspect that the weight is kind of evenly distributed around the foundation. In other words, usually one part of the building doesn't weigh substantially more than another part. Now, that's not always true, but at this level of what we're doing, it's true. So each of these little arrows is some equal part of the weight of the building, and so the full weight of the structure is spread all the way around. And so that weight has to be supported by dirt or rock or gravel or what they call the building pad. And if you just pour dirt or gravel or rock into place, you don't know what it can handle. You don't know its limit. You don't know how many pounds that building pad can weigh. So if we had a building pad that was 1,000 square inches and a building that weighed 1,000 pounds, we would be kind of pushing down at 1,000 pounds per square inch. And that is a number that we do know about different types of soil. Different types of soil, we know how many pounds per square inch it can hold. And it's real interesting. Geotech people know it when it's dry and when it's wet and when it's old and when it's new. And, you know, they have tons and tons and tons of data about this. And then because they have the data, they've been able to really look at the structure of soils, and they've been able to become predictive. In other words, if you know the structure of your soil, And when they talk about the structure of the soil, they talk about the material composition, the size, the shape, and how well it's been mixed and how well it's been compacted. So, talk about a cooking recipe. It's really complex. All we need to know for this class is soil specifications along with compaction specifications tell you how strong your soil is. And if you know how strong it is and you know the weight of the building and how much it's spread out, you can compare the two to make sure that your building pad is strong enough for your building. Now, as an example, let's say that you had a building pad that was 1,000 square inches, just because it's easy to work with. And that's not very big. It's 100 inches by 100 inches, which is like less than 10 feet by 10 feet. Okay. But let's say we have 1,000 square inches and we have a building that weighs 1,000 pounds, and we put it on it and it says, okay, that's 1,000 pounds per square inch. My building pad can carry 5 pounds per square inch. Well, that means I could put another story on there without any problems. I could make a 2-story building and still be within the limit. And I could even put a 3-story building on there. Now, some architects and civil engineers would go, no. You need a safety factor. You need this, you need that, blah, blah, blah. And so different engineers will look at that comparison differently. Your job is to know that you will compare it, and that is one of the limits to how tall a building can be, is that you're putting more and more and more weight on a fixed area, and you get near that limit that your soil can handle. Okay, so that's what that's all about. And you compact according to something called a Proctor test. Have any of you read it yet? Have you gone through the reading? The whole series on Proctor test that I'm expecting you to read and to kind of think about. But this now tells you, oh, that Proctor test means that I'm finding the best compaction to do this. Okay? And once it's compacted as best as it can be, we can test it and see how it did. Okay? So that is part of the thing about dirt. Now, we also know from what we went over on Tuesday that if my bulldozer comes through and makes this pad, and my surveyor says, yep, you got it just right, and it's nice and even, and it's mixed properly, it's got all those cooking ingredients, it's got the right size gravel, the right size soil, the right amount of organic material, the right amount of colloidal material, it's been mixed properly, and I've dampened it properly, I can come in and compact it a certain percent. And when I get that certain percent, I'll get how much the ground can hold. But I know that I'm also going to reduce the level, the elevation of this when I compact it. And that's what that little calculation is about. And sometimes it's not very important. I'll maybe compact it 1/8 of an inch, or maybe even 1/8 of a foot, 1.2 inches or so. And that won't mean anything. But sometimes it really does mean something. And so, especially if you've got some tricky drainage and things. So that calculation is kind of important. And engineers may expect you to be able to figure out a percent change in compaction. Okay? And so when you talk about soils, again, I want you to know, and you can put this in your notes and you can write it down, that there are certain sizes of material and certain types of material, and the mixture of those creates the right material for your pad. Okay, so there we go, and we'll go into that a little bit more when we talk about concrete, because concrete is a special situation of a building pad. So we're not going to talk about every kind of building pad possible under the sun, but we're going to talk about concrete and how we work those things out. Okay? So those are some important notes about that, and that's why I put that on there, and I wanted to go over it. The next thing to do is to look at these drawings. So let me pull up my VMware. If I can find it. So now you see my VMware. And I'm going to go ahead and do that assignment for you. So if you'll notice, I'm in VMware. I have logged into Adobe. I have logged into Google Chrome, and I've got this up so that I can go get my materials. I have my U drive open so that I can store my materials. And I've actually already downloaded it. And I've got Revit open. So that's my preparation that I went through. If I come over here, I can download those 3 files, but I don't really need them. But I'm going to download them anyway, just so that I've got them. One. Where are those? There's the second one. And there's my third one. So this is the process that you'll go through so that you have everything. It's all just good. It's all right there. And then, you know what? I like to have these kind of open and set to the side so that I can see them. So I'll come back over here. Let me reload that. That looks a little bit better. So I'm going to look at that first one, and I'm going to do that. So it says add spot elevations and contour labels. So you have to learn how to do that. Okay, so you do that in Revit. So I will open that Revit file. I have to go find it. I'll open my Revit file. Week 3. There it is right there. And everything you need is in there. It'll take a moment. I think it even has to update the file. Maybe. Nope, just opened right up. So now this is one. If I look at this, site existing. That's what it says right there. Site existing. Site existing. So if I can find that view, I can make those changes. There, remember it comes up with properties and then the browser. And there I see in the lower left, site existing. If I double click on that, it comes up. Site existing. And now I just have a few things to do to it. I need to do something called add spot elevations. Well, everything I'm asking you to do so far has been annotations. So if you'll remember under annotations, last time we added text. This time I'm going to do something called a spot elevation. What does a spot elevation do? Welcome back on, Mark. Um, it allows me to know the elevation at that point. Because look, when I'm just looking at it here, I don't know anything. I just see some lines in a shape. I don't have much information. And many times in a drawing, people want to know elevations. So I'm going to put this little target spot and I'm going to get it up to it. And for this one, I'm just going to double click and double click again. 2 double clicks. And I'm going to put it on each corner. And it can get a little bit hairy getting it right on the corner. Double click, double click. If I need to, I can scroll my mouse wheel forward to get on it a little bit better. Double click, double click. Click, double click. Click, double click. There we go. So that was how I add my spot elevations. But now there's one over here. And so I can either put it on the corner. Sorry, I'm going to zoom in. Right on that corner. There it goes. Click. And I can, even if I just click once, click, click. So that's another way to do it that's kind of cool. And then it says to add contour lines. Each of these lines means that if I were to walk along it, I'd be at the same elevation, the same height above zero, if I were to walk along that line. If I were walked from this line to this line, I would change elevation as I go. And so people want to know what those are. That's in another place. That's in a place called massing and site, because this is a site plan, massing and site, and they're called contour labels. So if I just watch this, click, I'm going to click my mouse in the upper right. I'm going to drag it across a bunch of these, going across all of those. Click, and it just puts them in there for me. It's the most awesome thing I've ever seen. And then you might want to put this one on. And some people will add this one. Many people won't. So just put there, it's done. That one's done. And you can just take a snip of that, or you can put it on the sheet called Site Existing. And there it is. Now, if I do it on this one, I want to make sure that I've deleted all of these notes because they're done. And change the name of the owner. And it's all right there. So you can take a snip of that, or if you want to, you can just take a snip of this work as it's finished up. Okay, so that was the first one. And remember, whenever you do anything good, save. Now, I do this demo over and over again, so I'm going to save it as a new project. And I'm just going to say week 3, ROS, complete. Just so I don't override my old one. Okay, so that was that one. Let's see what the next one looks like. There's C102. The drainage. Drainage. That says to put drainage lines in. And it says it's on one called Site Drainage Existing. Site Drainage Existing. Site Drainage Existing. So I'm going to go to Site Drainage Existing. And people want to know, where will the water go? And we use a slope symbol for that. again, the slope symbols are under annotate, and it's called a spot slope. At this spot, the slope is. And the slope is how steep something is. And so you just kind of make it cross some of these to give the idea of where water is going. Now, this one is kind of like, ooh, that one is not so good. Okay, but all around here, it's moving away. That's good. It's always moving away from my pad. That's good. And most of the time, it's moving toward my low point. So that's really good. This is what a civil engineer or even a landscape architect would go, huh, I know what I'm going to do. I'm going to put my detention pond over here. Or I might put a swale along this front road so that it all ends up over here. And over here, I know I have to protect my back edge. So where water goes, that's your site and soil. And what people would do on this is they would change the grading of the soil later on to meet their needs. So that's why this one is existing. Your landscape architect or your civil engineer might make a new construction grading that changes this, particularly if they're going to put in a driveway or a parking lot or any other kind of concrete or asphalt or hardscape to be added into here. So this is what's existing on the site now. It's a nice site. You know, if I were the engineer, I'd go, this is pretty sweet. I think I want to leave this alone as much as I can because it's nice. It's doing its job. Whatever I would want to do, I would try to make it as small amount of change to this as possible, because overall this is doing a very nice job. That making sense for you guys? And so again, in Revit, and Mark, if you have any, I mean, hopefully the Revit, the problems are solved, but I will be on campus on Friday from 10 until 2, actually from 9 until 2, if you would like to come into the lab and get some help with your laptop or something like that. But I think, Mark, you were very successful going to the LRC and seeing Jim. So that's good news that you can go to the Learning Resource Center to get help. Okay, so that's there, and I think there's a site for this. And so again, I will let you either, and I'm erasing the stuff, I will either let you take a snip of the entire sheet or a snip of just the one that you just did. Drainage. That's cool. So now our third one is your stormwater pollution prevention plan notes. Okay, these ones are so important. All of these drawings, by the way, are usually at least done in hand sketch form for the planning department whenever anything with dirt has to happen on a project. So any type of renovation where you're really moving dirt. Now, if it's very small, you don't have to do that. So many landscape contractors will not worry about some of this if it's a very small project. But if you start moving a significant amount of dirt, you definitely will. And now we'll go to the stormwater pollution prevention plan. And most planning departments have standard ones that they say, oh, okay, you're going to be doing some work with a tractor going on and off site. Here, just use this. but some larger ones have more. And so the goal here is to talk about TC1, stabilized construction, entrance and exit. And I hopefully you've done the reading of the best management practices to know what TC1 is for, how to do it, the good points, the key points, the when, the where, the why. And so that is part of your reading, and I'm going to ask you to go to your reading so you understand what you're drawing here. But stormwater pollution plans are very important, and they are strongly and strictly enforced so that you do not contaminate the stormwater system with pollutants or contaminants from your building site. And one of the prime ways that that happens is people driving onto the site and off to the site, on and off, on and off, and the wheels just pick up junk. And then they get into the gutters. And once they're into the gutters, they go into the storm drains. And once they go into the storm drains, they go into the public water aquifers and lakes and rivers and streams. And it is a problem, particularly with pesticides and herbicides and things that are existing in that ground over time. Heavy metals also from dumping and things like that. So I want to do a TC1. Now this is another annotation. Notice that almost everything we're doing so far in Revit is teaching you how to annotate, and I'm really introducing types of drawings to you. But that little rectangle is called a region. So there's a region, and I don't care how big it is. And I'm going to make a little rectangle, a rectangle region. Click, and just draw one in there. I'm not, click, click. There we go. And then over here, I think the crosshatch is fine, but you can do other things if you want. But the diagonal crosshatch, and click OK. And you now have a crosshatched region. That's pretty cool. And now we'll go back to that text thing again, and we'll put an arrow on it, and we'll write capitals TC1, and you can maybe even do an enter, stabilized construction, entry and exit. And then I click outside of it. Click, and it puts it somewhere. Now, if I click on it, it says that's really big text. So if I want to, I can check out a smaller text size. Why is that not letting me do my 1/8 size? Well, that's okay. I'll just leave it like that for now and move it. I don't know why I'm not getting my... I can change it there if I want. There we go. I'm not sure why that was not letting me do the 1/8 size because it's in there. So you can change that size or not as you wish. And look, you can move with these little knobby things here. You can move kind of how it looks and where you place it and things like that. So that's all you want to do on that one. And I don't think I have a sheet for that. There is no C105. So now you are at your option to just take this, take a snip of this, that's fine. Okay, or you can make a new sheet. And I'm going to show you how to do that. So if I go to my new sheets, I right click the sheet number, the sheet, right click, and I make a new sheet. And I pick my 11 by 17. And, oh, and there it is. And I can call it site work again. Now I have to get my view onto it. So I'll just come up here. There's my stormwater pollution plan existing. And I just drag and I'm done. Is that the coolest thing? So by the time you're done with this week, you'll have seen 5 different types of drawings. And you'll have started to learn about, what it means to work with the site and work with the soil, and the fact that is really it's the base. It's what everything comes off of. All of your utilities come in, most of them underground. Your foundation is put onto the building pad. Your drainage is done. Your stormwater pollution, your property lines are defined. It's really kind of a cool, your topo lines and your elevations are all set. This is the start of any construction project. Now, sometimes I'll grant you that if you're doing a remodel or a reconstruction, this is all maybe already done. And so you just go look up and resubmit what's already there. And you just show what you're going to change. But I like to start from the ground up and really work with this. Okay? So that's how you do it. So now I'll click Save again. And I remember that I can take all of my snips and save them and start working with them. And I'm not going to demonstrate all that. If you need help, just ask me. And if you put your initials on it and say that it's a complete, it really helps you figure out what's going on. So that's a little bit of file management that you might do. So there you go. That's how you do those. So I'm going to minimize all those, and I'm going to minimize that, and I'm going to come back to my lecture. And I'm going to come back to all the things I'm going to do. And I'm going to make sure that I've kind of covered everything. Covered the calculations, covered the Jamboard. I just covered these. On Thursday, we covered these. I didn't really cover the simulation too much. The idea is that you can just do that. To get Minecraft Educational, you just log on right here and use your W number, and you're in it. So you should be able to follow that right here. And I think I have to put in, I don't remember how I am in here. And I'm going to tell you, this is a super powerful construction management simulation. It's just amazing. And I can show you some shaders that architects, professional architects, are using Minecraft for their walkthroughs. Okay, so you can just follow the thing. I'm in Minecraft now, and I'm ready to go. And I can go get worlds and join worlds and look at my worlds and do stuff and figure out what's going on. Okay, so that's where we can go. That's how you do that. And so now I'll go ahead and get out of it. Where's my escape? Just hit escape and you exit. Okay? And it really is a pretty powerful construction simulation. You get to go through all of the phases. And if you get good at this, you can really do some nice simulations for clients. There's a guy who makes shaders. You can find him on Patreon. And he charges $10 a month. So $10 a month to get his shade packages and see what the guy does for Minecraft shaders for architects. You know how many clients he has on there? Take a guess. At $10 a month, Minecraft shaders for architects. He has 6,000. The guy makes $60,000 a month making specific shading tools for architects in Minecraft. I'm going, wow, that's what got me started using Minecraft for training. It is a real thing. Then I found out there's a company called FME Safe that does point cloud distributions into Minecraft for NSA, NASA, HUD, Department of Transportation, Stanford, Jet Propulsion Lab. They all hold meetings in Minecraft and look at models in Minecraft. And these guys use their shadings. So I'm going, okay, I can jump on board and I can do it. Okay, good. So Mark's doing okay. This is actually pretty powerful, cool stuff. We're doing it at a very simple level. If you're a Minecraft person, that's great. If you're not, find a kid who is, and they'll go, oh, you blah, 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 and they'll have it. I used to rag on my son all the time for spending time on that stupid Minecraft and those stupid games, and now I'm always going to him. Can you show me how I need to? And he goes, oh yeah, haha, you're coming to me now. And I go, yes, I'm eating my words. All that time you spent, you have a skill, and it's a skill that's used in industry. There you go. So that's my little spiel on that. That's why we're doing this stuff. But I think I've gone over everything. Does anybody have a question on CalTrans? Let me open up for a few minutes for questions on CalTrans and how to read it. Let's look up TC1 really quick. When I open it up, I can do a Control F and I can type in TC1. And I can go, okay, that's tracking control. Projects, there it is. It's part of mobilization. It's also part of earthwork. And it's also part of PCC and AC. I don't know what those are. I'd have to go look those up. And here's the actual one right here. Tracking control. And so you can see what it's for, what it's elevated. So this is how you do scanning. There's a document and you scan for it, looking up specific information about TC1. So you might make some keywords about what it is, what its application is. It's preventive instead of treatment. It's for dirt and mud. Keep it off of public roads. Here's a key point of the design. There's grading. Oh, aggregate. Oh, look at that. They're actually telling you your aggregate should be 75 millimeters or 150 millimeters, at least 300 millimeters in depth, and place it over a geo. So these are all specific things. And so when we start talking about soil, these are there. Alternate methods, you can use steel plates, not as good. You can use these weird kind of like bumpy plates. There's one where it's not going so well. So this gives you kind of an idea of what it's for and why you would do it. So that's how you go about reading one of these. So I thought I'd show that to you. That's what it means to scan. And you might go and get certain pictures and add keywords into it. So that's that one. I want to bring up the Proctor test. And so this is, what does settlement mean? You should be able to tell me. What does settlement mean? Soil types and grades. Look at this. This is all that we were just talking about. This is really cool stuff. Oh, there's a sieve test. We're talking about big down to small. These are all things that I would expect to see. I do not want to see reprints of these. That does not show me that you went to these. Permeability. What does permeability mean? Okay, so I'm looking for you to look at some of these. Okay, and I thought I had Proctor test. There it is. This is all about the Proctor test. Okay, and if you need to, you can just type stuff in, but here we are. We're at Proctor test. What does it do? What's it for? What's it like? Oh, look at this. These are different types of Proctor tests. What's good? What's bad? About different types. What does it mean? Cohesive soils, compaction. Oh my gosh. The expectation is not that you read all this, but that you know it exists. And so to know it exists, you would go, oh, I'm supposed to know about soil types and conditions. And so I would put in soil types and conditions and a link. And these pictures are really good, right? These tell you what happens when something goes wrong. Well, these things can happen. And those are not good. And so what types of soils are there and how do we calculate? So this is all cool stuff that's part of site work. And your goal is that you take, 6 hours of reading to do this. You want a good 6 hours of work. Maybe you only spend 2 or 3 or 4. If you can't spend that much, you just won't get as much out of the class. But I'm also trying to train you on how to do the work, on how to do it efficiently. So if we look at this, the idea is to write some keywords. Now, some people wrote keywords and all I saw were keywords. Okay, that's cool. Those keywords should find you images. So let's say one of them was Proctor test. And I found that. I can take Proctor test and either find it in these or put it up here and look for images and go, oh, I see what a Proctor test is. That's kind of a cool one. Let me copy that image and put it in here. And that's cool, but I would really like to know that you know something about it. Proctor test. It helps you determine the proper compaction of the building pad. Something like that. Okay, so, and then where did I get that? I got that from here. I got the link right there. That is what I'm talking about, of really doing a nice job of setting this up and having something that you can work with. Okay? So there's another little demonstration of what we're looking for through the rest of this. All right, that's really what I wanted to cover. Let's take a look at this. Your Revit file, you want to put your link here, and you want to put your C101 right here. Okay, so this stays here. You don't have to change this or this, but the link to your completed file in Google Drive goes here. Your completed file, and then put your image in here. And it can overlap it, and you can move this around to a better spot if you want. That's what I'm looking for on each of these. All right. There we go. Do you guys have any questions before we close off on that? Now we're getting into it, right? This is like, okay, I'm getting it. This is a real class. Those first 2 weeks were kind of like hokey pokey. Now all of a sudden I got to do a bunch of stuff. But this is really, really your start of construction materials and management. Dirt is your first construction material. Cool. Okay, then I'm going to go ahead and turn off the recording.